In physics, we can accelerate many types of particles, such as electrons or protons, using electric fields. But here's an interesting question. How can we accelerate neutrons? The problem is neutrons have no electric charge, so they cannot be accelerated using electric fields. Charged particles like protons and electrons can be accelerated using electric fields. This is the principle behind machines called particle accelerators. But neutrons are neutral particles. They have no electric charge, so they do not respond to electric or magnetic fields. Neutrons are usually produced in nuclear reactions or particle accelerators. For example, in nuclear fission, heavy nuclei like uranium split and release many neutrons. These neutrons can already have high energy, high speed. Even though we cannot accelerate neutrons directly, we can produce high-energy neutrons indirectly. One method is shooting particles at a target nucleus. For example, we accelerate protons or deuterons. Then they collide with a target material. During this nuclear reaction, the target nucleus emits neutrons. These neutrons can have high energy, high velocity. Another important method is called spallation. In this process, protons are accelerated to very high energy. Then they hit a heavy target, such as tungsten, lead. This collision breaks the nucleus apart and releases many high energy neutrons. In some cases, we don't want faster neutrons, we want slow neutrons instead. To do this, we use materials called moderators. Examples include water, heavy water, graphite. Through repeated collisions, neutrons lose energy and become thermal or slow neutrons. Neutrons cannot be accelerated directly by electric fields because they have no electric charge, but we can still produce them from nuclear reactions, use spallation sources, or control their energy through collisions. Neutrons are extremely important tools in nuclear physics, materials science, nuclear medicine. They help us understand the structure of matter at a deeper level.